Hey everybody, it's Jay Henry. In the last video, created a global template for the UI that we're creating in Next. And in this video, I want to actually focus on the API for getting predictions using our service and saving the prediction information as well as the image data and some other metadata about the image to an Elasticsearch instance so that we can use it later on and just pass the identifier for it through our pages. I'd originally experimented with actually passing the image data from page to page using a post and then trying to get it on the server. It wasn't very clean, and it was kind of fragile. If you refresh the page, it would not maintain your data through refreshes. So I thought maybe sticking it out in an external database, basically a caching layer, but less volatile than a true cache, might be a good idea. So what I'm going to do today is create the prediction API. And so the APIs that Next gives you out of the box by putting them into this API directory underneath pages have a slightly simpler kind of signature to them. Really, the only thing you need to do to create an API here is export a default async function that takes in a request and a response as arguments, and that's basically it. I'm going to wrap some error handling code around this. It tends to make my life easier. And then the way that these are actually going to return the data is we're going to give them a status. For success, it'll be 200. And then we're going to tell it we want to return some JSON. And right now this will be empty. In the case of an error, we'll probably want to log it out. Let's say an error maybe occurred. How do you spell occurred? Is that one C or two? I'm going to put two. Let's say while getting predictions for image, and then we'll actually log out the error message that we got with the error object. And then we'll still return a status, but we'll make it a 500. And we'll actually return the message. For response statuses, I tend to return 500s unless I know specifically what the error message is. And I try to return a valid HTTP response code whenever possible, but I try never to return a 404 because that I find very confusing when I'm trying to debug, and I try to reserve 401s, 403s for true authentication issues. So if we did this right now, I think this would actually work, but it's not very useful. And if we take a close this down. If we take a look back at what we're actually passing to this thing, we're going to be passing it a file. The content type is some type of file. And so I'm actually going to want to process the request here as a stream. And Next will let you do that, but you have to give it a little bit of configuration. And so I'm going to give it a config, and that config is going to have a single property body parser false. And what that basically means is that the API is not going to try to wait for all the data and then parse it all and give me kind of like a fully fledged like form with files and everything. It's actually just going to accept the data as it streams in. And so what we need there is a function for getting the data as it comes in and as a stream. And the Node API for doing that relies on callbacks. And so what I'm going to do is actually wrap those callbacks inside a promise so that we can use them, using async awaits. I'm not a big fan of nested promise structures and having to, do okay, return this, then this, catch this. I'd rather just, make it more declarative. So let's return a promise here, and then I will, let's see, we're going to need what we want to return from this is a buffer of data. And so we're going to need to collect that buffer as it comes in. So let's say data is equal to an array, and then the request object is going to fire a data event every time it receives data, a chunk of data. And so we'll call that a chunk. And every time we get a chunk, we're going to want to push it into data. So we'll say data.push chunk. And then once it's got all of its data, it's going to fire an event, an end event. And this won't contain any data, but this will be a trigger for us to create our buffer. Concat, and this will take all of the chunks in our data array and put them together into one buffer object, and then we can resolve that buffer. And so that this will give us a nice interface for dealing with getting this data, and it should be pretty well, let's just write it. Let's just see what it looks like. So I'm going to say raw data is await get data request. Now I'm calling it raw because you could upload any size image, and our API that we built is actually fairly fast, but if you are uploading really large images, the network latency can bog down the responsiveness of your client. And so we're actually going to use the Sharp library to resize this raw data down to something that's more manageable and something that we can easily save and pass around and reload. So I'm going to say resized is await Sharp, and then we'll give it our raw buffer there. And then this is, I think I might have mentioned, well, what did we do here? Let's give ourselves some space to move. Sharp has what I think is a pretty nice Fluent API. So we're going to feed in a buffer, and then we're just going to call resize. And the size of images that I've been creating are about 256 by 144. It gives our model on the API side enough pixels to work with, but it doesn't create such a large image that it's tough to pass across the network. And then we're going to call toBuffer, and this will give us another buffer object, but it'll be a smaller one. And so now we actually want to get the prediction. And so I call it predictions rather than prediction because it's actually going to return, if you remember way back from the computer vision model videos, it's going to return an array where each element in the array specifies the likelihood of a certain class. And so it'll look something like, it might look something like predictions will be in form 0.0, 1.0, and it's a softmax, so if we're going to do more than that, we'd have to do like 0.8 and then 0.2. It'll look like it's, something like that. And so it's not one prediction, it's actually a set of predictions. And so we're going to create a function called getPrediction, and we'll pass in our resized buffer to that, and then getPrediction is actually going to call the service that we created in an earlier video and pass in the image data. And so we're going to pass in an image buffer, which is our resized image buffer, but I want to be really explicit here that we are passing in an image buffer. I don't want to just say resized. And then we're going to get a API URL. And the API URL is, you could obviously hard code it here to whatever the DNS name of your load balancer is that you created in past videos. I've got it in the I think I've got it in this next config file, and so I'm going to load it from there so it's easy to service. It's easy to change later on if I want to, because it's, you know, in a config file rather than being hard coded. And then we're going to create, you know what, we're going to probably need to import something for that. A couple of things actually. So we're going to need fetch. Let's actually do this like this. Let's do this a different way. Concept short equals require. I don't know why I use double quotes there. I never use double quotes. Let's do that. That's yeah, I like that better. Const fetch. We're going to need the server side fetch that we installed. That's node fetch. And then we're going to need form data. Const form data. Yeah. Equals require form data. And so on the client side, these are native kind of objects that you can work with, but on the server side, you've got to get, you know, a node version of them. So we're going to say form equals new form data. This is exactly what we did in index, so we're just basically going to proxy this call through to our service. Let's see, formed append data. Now you could ask the question, well, why didn't you just call the prediction API from the client side rather than proxying this through to an API that's going to actually call that API? It seems like an extra trip, and you're not wrong about that. However, if you call it directly from the client side, then you have to set up cores and authentication and all that kind of stuff. Whereas if you call it server side, you don't have to set up cores. And because this is on the same domain, because it's a relative URL, there's no cross-origin issue here. So it makes it a little bit easier to deal with. But, you know, it is an extra trip. I don't think it's a huge one, though. Let's give this some options. Yeah. Let's say that the content, oh, come on, content type is going to be, so we know these are PNGs. We could pull it off of we could thread through the original content type and just, you know, make it so it's more dynamic, and, you know, you could totally do that. For now, I'm not going to. We're going to call it image data because that's what our service is expecting, and then we'll give it a file name, and we'll just call it default because I don't think it's important. So that's our form, and so this is basically, again, an HTML form that we're going to pass to our service. And then all of this should look very familiar. We're just going to call fetch, although remember it is the node version of fetch, so it does behave slightly differently. So if you get any weird error messages or anything that you would not expect from client-side fetch, just keep in mind it is, you know, a different thing. I'm going to post, and then we're going to do body is going to be the form. And again, fetch will return a object here that will then have a method on it called JSON, and we'll need to await that as well. So the predictions are going to be returned. You know, I said they look like this, but the service actually would accept multiple images, and the model accepts multiple images because obviously it works in batches. And so it's actually going to return an array of arrays. We only care about the first one because we're only passing in one image. And so we're going to say, we're going to await this promise, and then we're going to say, give me the first one. If you wanted to modify this service to take in multiple images and pass them all to the service at the same time, you could do that. I think you'd require some modifications to the service. I think it's looking for the first file there as well, but I don't think it'd be a heavy lift to do that. And then what we're going to do is I'm going to do something here to make my life easier later. So this is going to be an array, but I want to add some syntactical candy on top of it. I don't want just an array of numbers. I want to know what each of these numbers means. And so I'm going to call map on this and do a little bit of transformation on this. And that's going to require that we create a new kind of thing up here. I'm going to call this mappings. This is a, where did it go? Sorry. This is a leaky abstraction, so if you don't want to do this, don't. But what I'm going to do is I'm going to tell it positionally what those numbers mean. Might be a good idea to do that on the server side, on the service, the prediction service side, but I didn't do that, so I'm going to do it here. And so what I'm going to do here is we're going to return a new object here, and we're going to say that its name is going to be the name of the mappings at the place where it comes in. And then we are going to take the value, and this will be, so we're going to do a little something here too, which is we're going to take the value and we're going to multiply it times 100 because we want these to basically be percentage values, and you see they come in here. This would be an 80% likelihood. This will be a 20% likelihood, so we're going to multiply these by 100 to move the decimal over 2 places. And so the reason this works, the reason this index works, is that they always come in order. This is always juvenile. This is always seedlings. This actually isn't implemented. It's just here for example. And so the first one of these will always be the value for juvenile, if that makes sense. And I think that's all we need to do here. And so I think what I'm going to do here is, we just wrote a lot of code. We still have another step to do, which is we want to take these predictions and we want to save them to Elasticsearch so we can get them back later. But I'm going to pause the video here and just debug and make sure that everything's working before we get too much farther into it. So please stand by. Okay, I'm back. There were a couple of small problems. I think there was a leading space in the method which was not valid, and I needed to put new in front of this promise, but I added a console.info for predictions, and you can see the service is actually returning the data to us, the predictions that we want. So yeah, well, here I can just show you in real time. So if I browse, we're in let's go to the juvenile, and we'll pick a juvenile plant. We will get a prediction, and then we will see that it predicts that it is a juvenile with 100% certainty, and it is seedlings. That's so funny. Seedlings at 0%. So I think we're okay now to move on to the next part of this particular service, and that is saving the data to Elasticsearch. And so what we want to do with that is I've got an Elasticsearch cluster running, and again, I'll probably set something up, like a video, to show you how to do that with Terraform, but it's it's like a 5-minute thing. It's very simple. But what we're going to do is we're going to convert the image buffer that we have into base64 encoded string. We're going to attach some metadata to the image buffer. We're going to save the image buffer, the predictions, the metadata in Elasticsearch, and then we're going to get back a unique identifier from Elasticsearch that we'll use as our image key. So we're going to need a new function here, and this function will take in the image buffer. Again, I like to be explicit about that. It'll take in the predictions that we just got, and then let's do some processing on them. So the first thing we're going to do is we're going to say that the base64 encoded image data is image buffer, and then we just call toString on it, and it's got a built-in argument for base64. It's super handy. Elasticsearch is great for saving base64 encoded strings. We're going to create some metadata for when this was created, and we'll just give it a new date right now, and we'll format it later on. It's better to have it all in there, I think. And then we will create the Elasticsearch data, and this will be what we actually send to Elasticsearch. And so here we're going to have our predictions, we're going to have the image data, and then we're going to have created, and anything else, literally anything else you wanted to attach to it, you could. One of the nice things about Elasticsearch also is that it's schemaless, so you could, add these 3 pieces of metadata right now, and you could add a 4th or a 5th later, and you wouldn't need to change your schema. It would just create a new record that has those, and the old ones would continue to work. So we're going to use the same kind of trick where we get the URL out of our config. The difference being that we're going to add some information to it. So we basically got a process.env, and I think I called it ES cluster URL. But we're going to, in addition to that, tell it which index we want to use, and we're going to tell it to use doc. And so what happens is if you this index, first of all, if it doesn't exist, it'll be automatically created when we send our first document. But if you use _doc, then each call to this endpoint with the same data will either create or update the document. We're going to be using a post verb, but it acts more like a put verb. If there's also a create endpoint, but it won't do the updating, it'll only do the creation. So if you have never worked with Elasticsearch, it has a fantastic REST interface, and you can call it just like any other RESTful service to save your data, which I really appreciate. I'm going to be using a post verb here. We're going to add headers to let it know that we're using JSON here. And so our content type will be application JSON. That's good. And then we're going to stringify the body and pass that in. So stringify, yes, data, and then doc info. If we await a result, that will give us back a JSON object that represents the state of this document inside of Elasticsearch. And inside there, we can pull off the auto-generated unique ID for this document and return that. And that'll actually be our image key. And so to call this, all we have to do is come back up here. We've got our predictions. We can take out this log, and we can say image key equals await, and save image, passing in our resized image buffer and our predictions. And then that's really all we have to do, and we'll just return this image key to the client, because that's what the client is expecting, is this image key. And so if we've done this right, what should happen is we should get back an image key here, and all of this data should have been saved to Elasticsearch. And when we build our next page to actually display the predictions and the image data and everything, we'll reach back out to Elasticsearch and pull the data back down. But for now, I'm going to pause, make sure everything's working correctly, and then if everything's working, I'll unpause and do a small little demo. So stand by. Okay, did have to make one small change. I had put the body tag inside the headers tag when calling Elasticsearch. Obviously, that is not going to work. Everything else seems to have worked okay, though. So if we come back over to index, we're going to log out the image key. And so let's actually make a prediction and see what happens. And you'll see here we have an image key. And that means that it was successfully saved in Elasticsearch. In the next video, we will use that image key and pass it over to another page where we will call out to Elasticsearch, grab the data that we just saved, display the image and the predictions on the page, and I think after that we'll be ready to talk about next steps of creating a list of lots of different images and their predictions, but that's, that's in the future. If any of this was useful or if you learned anything, please like and subscribe. If I did anything wrong or you see any major glaring errors or ways that things could be done better or more efficiently, please leave a comment for me so that I can learn from it. Otherwise, thank you for watching, and we'll see you next time.